What if I told you that addiction isn't about willpower, but about how your brain literally rewires itself? Today we're exploring 5 crucial questions that reveal the fascinating and often misunderstood science behind addiction. First question: what actually happens in an addicted brain? When someone uses an addictive substance, their brain releases massive amounts of dopamine in the reward pathway. This isn't just feeling good, it's your brain screaming that this experience is essential for survival. Over time, the brain reduces its natural dopamine production, requiring more of the substance just to feel normal. It's like turning up the volume so loud that regular sounds become whispers. Second question: why can't people just stop? Here's where it gets fascinating. Addiction hijacks the prefrontal cortex, the brain region responsible for decision-making and impulse control. Imagine trying to make rational choices while your survival instincts are screaming at you. Brain scans show that people with addiction have measurably different neural activity in areas controlling judgment and self-control. Third question: are some people more vulnerable than others? Absolutely. Genetics account for about 50% of addiction risk. That's similar to diabetes or heart disease, but it's not just genes. Trauma, mental health conditions, and early exposure all play crucial roles. Your environment literally shapes your brain's vulnerability. Fourth question: why do people relapse even after treatment? This reveals addiction's most cunning feature. It creates lasting changes in memory and learning circuits. Environmental triggers can activate powerful cravings years later. It's like your brain has a permanent bookmark for the addictive experience. This explains why addiction is considered a chronic condition, requiring ongoing management, not a one-time cure. Fifth question: what does recovery actually look like in the brain? Here's the hopeful part: brains can heal. Neuroplasticity means our neural pathways can reorganize and rebuild. Studies show that after sustained recovery, brain function can significantly improve, though some changes may be permanent. Recovery isn't just about stopping use. It's about rewiring reward pathways and rebuilding decision-making capabilities. Here's a striking fact: addiction affects the same brain circuits involved in learning, motivation, and memory systems that evolved to help us survive. In a twisted way, addiction represents these systems working exactly as designed, just focused on the wrong target. Understanding addiction through neuroscience doesn't excuse harmful behavior, but it does explain why simple willpower isn't enough. When we view addiction as a complex brain disorder rather than a character flaw, we open doors to more effective, compassionate treatments that work with the brain's natural healing abilities rather than against them.